if you are actually seeing my screen. Are you see what I'm projecting right now?
Yes.
Okay, thank you so much. And I want to welcome you to my lecture today. Like I said, uh, this is actually uh, going to be a party, okay? It's going to be a probability party. And I want a situation whereby I'm going to do that in a way we are all going to enjoy this party. Okay, so the topic is just going to be further topics in probability part 2, because I'm actually going to start from where we stop on Monday. That's exactly what I'm going to do. Okay, so of course, the suggested area to read in the textbook, we are still on chapter 2, and the focus this week is actually going to be on chapter 2. Okay, the outline for today, I'm actually going to walk you through conditional probability, the basic rules of probability, and lastly, we're going to talk about the law of total probability and the Bayes rule. And of course, uh, the examples I'm actually going to cite today, you're actually going to like it, because it's actually going, you're going to see how the knowledge of probability can be used in the court of law, in litigation. Okay, so you're going to see the application of that today as well. But you know what? Before I move forward, I actually want to give you a clue on the assignment, because I know some people were not able to reach out to me during my office hour yesterday, and you may actually have one or two things, or maybe you need one or two clarification. Okay, today, before I go to my lecture, I'm actually going to tell you some, give you information. Uh, Let me confirm again. Are you guys hearing me clearly?
No.
Yes.
Yes.
Oh, okay. Oh, yes. Okay.
Yes.
Okay. Thank you so much. Thank you so much. Okay. Like I said, if you want to answer any probability question, if you look at the assignment that I gave you, if you want to know the right formula, probability formula that you're actually going to use, then you need to be able to differentiate between different types of events. If you are able to differentiate between different types of events, of course, you would, because any probability question, is you know is being carved in a way it's around events. Okay, and that is the reason why the moment you are able to know the types of event, the moment you're able to identify from a question whether the question is about independent event, whether it is about mutually exclusive event, whether it is about non-mutually exclusive event, or whether it is about conditional event, if you are able to identify the type of the event in the question, okay, I want to tell you that you actually, it's going to be so easy, okay? And that is the reason why you need to follow first, figure that out, okay? And of course, any of these events, if you look at any probability question, it's about events. It is now left for you to identify what kind of events. If you identify an event to be a mutually exclusive one, a mutually exclusive event is either this event occur or the other one occur. In mutually exclusive event, no two or more events can occur together. In that situation, that will actually attract an additional rule. Okay, additional rule where I need to add the probabilities. Okay, but if I'm talking about independent events, what do I mean by independent events? Events that can occur together. Okay, events that can occur together. They cannot occur separately. They can only occur together. That's an independent event. And if they can occur together, then that will actually attract a multiplication rule. Oh, somebody said, did I miss the party? Oh, you are not missing. Join us. We're having a party so that you don't miss the probabilistic cookies and the candies, okay? You are not missing anything. Okay, now when you talk about non-mutually, So, like I said, in the independent events, when you have events that can occur together, of course, that will attract a multiplication rule. Okay, you're actually going to multiply the respective probability. Now, when you talk about non-mutually, I'm going to say that again. Non-mutually. Non-mutually does not implies mutual. Does not implies independence. When I say non-mutually, I'm actually saying that if I have two events, it's either they can occur separately, okay, or they can occur together. The non-mutually, we actually give we attract a law in mathematics that we call the law of inclusion and exclusion. The law of inclusion and exclusion. Okay, I got two events, they can occur separately and they can also occur together. Then it means the formula that I'm actually going to be using is going to be probability of A union B will now be equal to probability of A plus probability of B minus probability of A intersection B. I can remember in part of the question in the assignment where I actually wanted to find the probability of, of whether certain thing will be delivered on time. And you got two of them. Okay, so in that situation, it's either one is delivered on time or the other one is delivered on time or the both are delivered on time. And that is the probability that at least one is going to be delivered on time. So like I said, if you really want to know how to answer any probability question anywhere in the world, what you need to identify, what kind of events are we talking about? Is it independent? Is it mutually exclusive event? Is it non-mutually exclusive event? And so on like that. The moment you are able to identify the event that you are talking about, of course, you'll be able to know the formula in probability that you're actually going to use. Okay, because of the, now I'm actually going to move to the next one now, which I call conditional probability. Now, when I talk about conditional probability, the conditional probability is actually talking about, of course, what is the probability of the occurrence of an event, okay, in the light of observing another event, okay? And that is the reason the mathematical implication of that is that it's actually this, like, okay, if I'm looking at the occurrence of B and I've observed A, or what is the probability that B is actually going to occur, given that I have evidence about A, given that A has already occurred? Mathematically speaking, this is exactly what I'm going to have. It's going to be, this guy here is just going to be the ratio of the joints of the two events to the marginal. What is the marginal here? Of course, before B occur, A must have occurred. Therefore, what I'm going to have in the denominator right here is actually going to be the probability of A. Okay, because what I'm looking for is the probability of B occurring, given that A has already occurred. Okay, now and the same thing also applicable. What I have here is more or less like I'm talking about hand. Okay, so I'm talking about joints. Okay, what I'm touching on right now is just the probability of the occurrence of the two events, the joints. Okay, the ratio of that is actually going to give us the probability of B given A. Okay, now this is what we call conditional probability. Of course, in the conditional question, they must, you're actually going to say given. Okay, for you to know you are actually going to use a conditional probability. Okay, now I want us to go into an example right now. So if you take a look at what I have here, in a recent study, it was found that the probability that a randomly selected student is a girl is 0.51. Okay, now if it is 0.51, that is talking about marginal. That is, it means that is just focusing on gender. It's focusing on a girl. That's a marginal. Okay, and is a girl and play sport is a 0.1. You look at the word hand. Can you see what I'm, okay, I need you guys to confirm if you, are you seeing what I'm pointing at right now?
Yes.
Yes.
Okay, thank you for confirming that. Thank you so much. Okay, take a look at that. They said it's a girl and is playing sports. Of course, that is a probability of a joint. And if I use X, if I use S to denote sports, and I use F to denote a girl, then the probability of the joint, okay, is actually 0.1. Now look at the question here. If the student is female, what is the probability that she plays sports? Now, the question they are asking you right here is going to be a conditional probability because she has to be a female before she plays sports. And that is the reason why the event of being a female will actually come first. And what we are interested in right now is just to see whether she plays sports. Of course, this is what they're asking about, and this is going to be the formula that I'm actually going to use. Therefore, the probability that, you know, she's a female, okay, and she's playing sport, okay, the probability that she's playing sport, given that it's a female, is 0.1961. And the 0.1961 right here is very, very small. Okay, but that doesn't mean we don't. That doesn't mean we don't have female that play sports. Of course, we have female that play sports. Okay, now that is that. I'm going to go into another one. You know, if you take a look at this question right here, at times they may give you a conditional probability, and they ask you to figure out the probability of joint. Okay, and in a situation where that occurs, and that is more or less like a dependent event. It's more or less like a dependent event. Now take a look at this guy right here. The probability that a randomly selected student plays sports if they are male is 0.31. So which means you have already been given a conditional probability in this question. You've been given a conditional because they said selected students play sports if they are male is 0.31. This is not a probability of a joint. This is already the probability of, the conditional probability has already been given. Okay, now right here he said, what is the probability that a student is a male and plays sports? Look at the word hand. Anytime you see a hand, then they are actually asking you to figure out the probability of the joint. Now take a look at that. It means this is what I'm looking for. Okay, and what we use to display the probability of the joint is where you are talking about the two events intercepting one another. Okay, and that's exactly what you're looking for. Of course, if you want to find that, and you know this is the formula, then I need to be giving the probability of male. Now, what is the probability of male? And we're told right here that we say, what is the probability that the student is a male and plays sports if the probability that they are male is 0.49? And that has already been given right here. Then I can actually figure out, you know, what I use X to denote is what I'm looking for, because I'm actually looking for the probability of a joint. Therefore, the probability of a joint is this. Now, what I've explained to you right now is just for you to be able to look and see the difference between the probability of a joint and the conditional probability. I think I need to read my chart. Let me see. I think somebody asked a question. Somebody said, what is the difference between play sports if they are male and is male and play sport? Oh, that's a very good question. Okay, if they say the probability that he plays sports if, look at the word if. Anywhere you use the word if, that's a conditional. In English language, that's a conditional statement. If, that's a conditional word. Now take a look at that. So that means you're asking about conditional probability. But a situation where they say, you know, there's a conjunction, okay, and they use a conjunction and, A-N-D, then that's a product, okay? And that's exactly what we mean. Okay, so I'm going to move right now to the next. Now, I'm taking you to another example right now. And in this example, you are given what we call a table of cross tabulation, where, a recent survey asks 100 people if they thought women in the armed forces should be permitted to participate in combat. Okay? And the results are, are given right here. Okay? Now, you conduct an opinion poll. You actually want to, measure the perception of people, okay, about whether women in the army forces, or whether they should be allowed to participate in combat. Okay? And you know what? In a survey, actually, you use 100 people in a survey. Okay? You use 100 people, okay, in a survey. Now, when you take a look at that, can you guys see what I'm pointing at right now? I'm pointing at a figure 100. Can you confirm if you're seeing that? Okay. And are you guys still hearing me?
Yes.
Thank you so much. Thank you so much. Okay, because I always want to confirm because of internet at times. Okay, now when you take a look at this, the number of people that say yes is 40. And the number of people that say no is 60. The number of male, of course, equal number of male and female were used in this survey in order not to create bias. Equal number of male and female were used in the survey in order not to create bias. Okay? Now, when you take a look at what I have here, this is a table. From this table, so many questions can be asked. We can ask you to figure out the marginal probability. We can ask you to figure out the conditional probability. We can ask you to find the probability of the joint. And we can also ask you to figure out, the probability that has to do with the non-mutually. Any question can be asked on a table like this. Okay, now let's go to the question now. Now look at the question A. It said, find the probability that they answered yes, given, look at the word given, that they were female. Given. Anytime you see given or if, you may see given, the word given, or you see or you see if. Of course, that's what they are telling you to do is, to figure out conditional probability. Okay, and that is what that's what I put right here. Of course, Y here is representing yes, and F is a symbolic notation for female. Of course, if I have this one now, then the formula that should come to my mind is actually going to be this. That's going to be the formula I'm going to use. Okay, if I want to do that now, it means the very first thing I need to do, what is the probability? What is this probability? What is the probability of the joints? Checking the table, the probability of the joint. If I want to figure out the probability of the joint, of course, what I need to do, I need to know what is the number of respondents at the point of interception in the table between yes and female. I'm actually going to come here. This is a female. This is yes. The number is 8. Okay. Now, then it's actually going to be 8 over 100. And that's what you are saying right here. 8 over 100 is this guy here. Okay. Now, if I were to figure out the probability of female, the probability of female is actually a marginal probability. Of course, I need to know the number of female in general. That's 50. Then the probability now is going to be the number of female in general divided by the totality. Okay, and that's going to be 50 over 100. By the time you simplify that, you're actually going to have that result. Is there anyone in this party, okay, who doesn't understand how I figured that out? Is there anyone? Like I said, you pay for this service. Do not hide your feelings. You pay thousands of dollars. That's not, it's not easy to get thousands of dollars. Ask question. I want everybody to be happy in this party. Are you guys happy in this party? I need you to say yes. Are you happy?
Yes.
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 Oh yeah.
Yes.
Good job. Thank you
Yes.
so much. Good job. I'm
Absolutely
so
nothing is
excited.
Absolutely.
Okay, thank you so much. Now, that is how to figure out the probability of yes given female. Okay. Now, the next thing I'm actually going to do right now, another question that we want to do, they say find the probability they were male, given that they answered no. Okay. Now, it's going to be the probability of male giving the answer no. Can you see that now? That is how to interpret that. Okay. I think you can see that right now. Now, we take a look at that, then it means I need to be able to figure out what is the probability of the joints and divided by the probability of no. Okay. Now, when you take a look at that now, the probability of, of M giving no, of course, I need to go to the table. What is the point of intersection between male and no? And that's going to be 18. And of course, the probability associated with that regard is actually going to be 18 divided by 100. And if I want to know the probability of no, then what I'm actually going to do is actually going to be what is the total number of people that say no? And that's going to be 60. And what is the probability associated with that? And that's going to be 60 over 100. And that's exactly what I have here. Then the probability is 3 over 10, which is 0.3, or something that you can actually call 30%. Okay. I'm going to move forward now. Now I'm done with the conditional probability. Now, the next thing that I want to talk about now, based on what I've been teaching. Okay. Now, I want us to revisit basic rules of probability. Of course, we are more or less revisiting what we have done before, because if you really want to answer probability question, of course, you need to be able to know the axioms. You need to know the rules of probability. I want to say, if I want to live in Chicago, if I want to live in the city of Chicago, then I need to be able to follow the rule. Otherwise, if I don't follow the rule, I'm actually going to land in jail. Or if I want to live in the city of Minneapolis, of course, I need to live by the rule. Otherwise, I'm actually going to get into trouble. And the same thing also applicable to probability questions, okay? If I want to get things right, of course, I need to know the rules. Just like you are in my party right now. The rules in this party is just like, okay, if you want to get the information I'm passing across, then you just need to pay attention. And if there's any area you don't really understand, please ask questions. Okay, now I'm going to go into the basic rules right now. Now, I'm going to call the rules probability axioms. Okay, the probability axioms. Okay, and you know what? The probability axioms, they are just the rules. What are the rules that guide probability? Number one, and before I go into that, of course, if I have any events, okay, and of course, event is a subset of a sample space. What do I mean by sample space? Sample space is a collection of possibility. Okay, it's just like the totality of respondent. Okay, and of course, the events. Of course, if I want to talk about University of Minnesota right now, maybe I'm talking about the University of Minnesota students. That's a sample space. Now, if I'm focusing on this class, that's an event, because this class is a subset of University of Minnesota. And you know what? The probability, if I'm looking for, so I'm going to be using E for event, which is a subset, and I'm going to be using S as a sample space, collection of possibility. Okay, when you take a look at this law right here, is trying to tell us the probability of any event lie between 0 and 1. Okay, the probability of any event lie between 0 and 1. If you are calculating probability, if you get a result, okay, greater than 1, or you get a result less than 0, then you are wrong. Something is wrong, because the result must lie between 0 and 1. Okay, inclusive. Now, when you look at number 2 right now, what you see in the parentheses right there is a symbolic representation of an empty set. Okay, at times, if I'm looking at the point of there's possibility that if two events don't occur together, if there is no common ground between two events, therefore the probability associated with the occurrence of those two events will actually be equal to 0, because what you have in the event is empty. Okay. Oh, maybe you want to be before you can be someone's friend, you need to, four of us, be able to identify, do you guys have a common ground? If you don't have a common ground, then you're going to say, oh, you are not going to be my friend. Because before you can be my friend, we need to have something in common. Okay, in a situation whereby that event is empty, then it means the probability that we're actually going to have something in common is actually going to be 0. Okay, so when I'm talking about the probability of an empty set equal to 0, okay, that's exactly what I'm trying to explain. Okay, now when you take a look at number 3 right now, if I have a sample space, which is a collection of possibility, okay, now the probability of a sample space is actually going to be 1. Why is it 1? Because that's a sure event. At least one of the events in the sample space is actually going to occur. And that is the reason why the probability of a sample space is actually going to be equal to 1. Okay, now the next thing that I'm actually going to talk about, we are still on the probability ancients, is number 4. And of course, you're going to use one of the assignments that I've given, you're actually going to use this number 4. This number 4 is not mutually exclusive. What do we mean by non mutually exclusive? Non mutually exclusive actually implies that there's possibility that the event that I'm talking about, if I'm talking about 2 events, one can occur separately, the other one can occur separately, and they can also occur together. And if they can occur separately and they can also occur together, and that is the reason why we're always going to call this the law of inclusion and exclusion principle. That is inclusion and exclusion principle, because you are adding and you are subtracting. Okay. Now, if you take a look at number 5, the number 5 is just basically talking about mutually exclusive is either this occur or the other one occur. If you take a look at number 4 and number 5, I'm still talking about union in 2 of them. I'm still talking about union. But only that before I can apply number 4, of course, I have to be dealing with the non-mutually exclusive event. And if I want to talk about number 5, then I'm going to be talking about mutually exclusive event, situation whereby 2 events cannot occur together. Okay. Now, number 6 now is talking about the rule of complementary events. Okay, what do I mean by complementary events? If I have a sample space, which is a collection of possibility, for instance, department in the University of Minnesota. If all departments in the University of Minnesota happens to be, they are in my sample space, I take in mathematics. I think we call that universal set. Okay, that is a collection of possible departments we have in that university. Now, if I'm interested in this class, there are so many classes in the University of Minnesota. If I'm interested in this class, then I'm going to call this class event E. Now, the other classes that I'm not interested in are the complements of event E. I'm going to say that again. When you want to talk about the complement of an event, then it means other events in the sample space that is different from the event under consideration. And you know what? This class right now and other classes in the University of Minnesota, by the time I put them together, they're actually going to become the University of Minnesota. And that is the reason why the probability of this class and the probability of the rest of the class that I don't talk about in the University of Minnesota, when I add them together, it must be equal to 1. And which means if I'm interested in the probability of the complement, take a look at what I have right here. If I'm interested in the probability of the complement, then it's going to be equal to 1 minus the probability of that event. So this is more or less like, okay, I'm not interested in male. If I'm not interested in male, then what am I trying to get? I know that the probability of male and female will be equal to 1. Then I can determine, if I know the probability of male, I can determine the probability of female. Because the male and female are mutually exclusive. When two events are mutually exclusive, if you add their probability together, it must give you 1. Now, I believe you understand what we mean by complement now. Okay, I think I put other exercise here that you can just take a look at that. I put a solution right here, okay, just for you, okay? You can look at that. And this is another exercise, I put a solution, you can also look at that, okay? And this is another one, okay? Now, please make sure you read that, because something like this may be part of the midterm one, okay? Now, take a look at that. I put the solution right there. Now, I want to go into the last outline for today. And this outline is very, very, oh my God, I love this particular area. And you're going to see the reason why I love this particular area very well. Okay, before I move to this particular area, are you guys still enjoying this party? Sure? Are you still enjoying the party? Can you guys still hear me?
Yes.
Oh my
Yes.
God, they are still enjoying the party. Please don't sleep. Please, okay? Only that I'm sorry, I'm not going to give you cookies, but I'm giving you statistical cookies, okay? Sorry about that. Okay, now, we want to talk about the law of total probability, okay? And the Bayes rule, okay? That's exactly. Oh, somebody says statistical cookies are the best. Thank you so much. Thank you. Okay, so now I want to go into more logical thing. Please, I want you to pay attention. Where we are now is critical. Where we are now is critical. Okay? Because when you understand the law of total probability, you're actually going to understand the Bayes rule. Of course, and we apply all this either in engineering, in medicine, and even in the law, and even in the court of law. Okay? Please, I want you to pay attention to this right now. This is what we're going to be doing for the next 16 minutes. Please pay attention, because I want to assure you it's going to be mathematical. But you know what? If you can just focus on this slide, and you're going to get things so easy. Now, let me start with a sample space. In a sample space, we actually have the collection of possibility. Okay? We actually have the collection of possibility. Okay, now if you take a look at the sample size right here, we got 1, 2, 3, 4, 5, 6. What I'm just trying to talk about is, okay, in my sample space, how many possibilities do I have? Okay, now let me take a look at this line. This one is actually talking about, maybe I'm talking about a die. In a die, we got 1 to 6, right? Okay, then the collection of possibility is actually going to be 1, 2, 3, 4, 5, 6. Okay, now if I want to go general, okay, if I want to go general, and I want to talk about sample space, okay, now, and I want to talk about that in terms of several events that we may actually have in a sample space. Okay, now look at A1. Oh, we got A1, A2, A3, A4, up to AN. Now, if you really want to understand what I'm explaining right now, I want you to be looking at these as classes in the University of Minnesota. Oh, A1, maybe our class. A2, another class. A3, up to AN. Okay? Those are the classes in the University of Minnesota. Okay? Now, the sample space is actually going to be A1 junior, A2 Junior, because it's either you are in this class right now and you can't be in another class. That is categorical, okay? But you know what? When I pull all the classes together, of course, I'm actually going to have the sample space, so which means all the events right here are mutually exclusive. You got to belong to one at the same time, okay? Now, if we have that, now let's say that we're looking at another event, which we call B, okay? Let's say we're looking at another event B. And you know what? The event B that we are talking about, okay, we can actually have, if I'm looking for event B, of course, we need to be, and we need to visit each of those classes. Oh, what am I talking about here? If I'm looking for event B, it's either I come to maybe A1 class and try to figure out event B, or I go to A2 class or figure out event B until I get to AN class and I figure out event B. So which means what I have right here is the union of the joints. What is the joint? We got a lot of joints. Okay, we're looking for an event B. Okay, we go to A1 class. We're looking for the same event B. We're actually going to A2 class until we get to the last class. Okay. Now, if I'm looking for event B, what is the probability of that event that I'm looking for? Okay, what is the probability of that event that I'm actually looking for? Now, let me tell you something. I'm going to, let us assume that I want to know those who normally go to TCS Stadium to watch Vikings. Have you guys heard about Vikings? You know, for those of you that are not from United States, the Vikings is a football club representing Minnesota. Okay, to the best of my knowledge, it's not only Vikings. I think they also have was it Govers? If I'm wrong, correct me. Okay, I know there's one that is representing the University of Minnesota, and I know there's Viking as well. The two of them play football. For those of you that are not from United States, this is not soccer, okay? Because in Africa, you know, when we talk about football, we talk about what United States calls soccer. But this football is this American football, okay? Now, let us assume that what I'm interested in is to figure out the probability that is, student from different classes in the University of Minnesota visit maybe stadium to watch maybe Vikings. Okay. Now, what I'm trying to talk about here is that it's either people from this class, A1, okay, it's either they watch Vikings or people from another class watch Vikings and so on like that. And that's why you see a plus. And a plus is actually indicating either you get that from this class or you get that from the other class. Okay. Therefore, what I'm adding right here is what we call the law of, that's what we call total probability. Okay. That's what we call total probability. Okay. I'm talking about the probability of B. Okay, now if I want to come to this side right now, I want to visit each joint. Take a look at this joint right now. This is the probability of A1 intersect B. What is the probability that somebody in A1 class actually watch Vikings? That's what I'm talking about right here. And you know, if I want to do that, I'm actually going to split this to this, and that is going to be conditional. It's going to be conditional. It's not going to be an independent event. It's not going to be an independent event in the sense that there is possible. Of course, the class exists, right? That is going to have the probability of the class A1, the probability of the class. Then this guy is going to be what is the probability that, you know, I got some people here who have been to stadium to watch Vikings, given that they belong to this class. I'm going to do that to all the class. If I do that to all the class, what I have right now is what we call total probability. Okay? That's what we call total probability. Now, when you take a look at the picture that I have right here, you're going to see that A1, A2, A3, up to AN, they constitute the sample space. But what am I looking for? What I'm looking for is something, look at the cycle right here. What I'm looking for is something that is general to all the classes, which is B. And that is the reason why I actually want to, if you look at all the join, you're going to see B as part of that. That's exactly what I'm trying to figure out. Okay? Now, when you take a look at that, then we're going to have something right now. So, like I said, when I talk about the law of total probability, that is, I actually want to find the probability of B an event, okay, then it's going to be equal to this. Because, like I said, what was partitioned into this is the probability of A1 given, A1 intersection B, okay? If the probability of A1 intersection B that is what this is representing, because it's actually going to be a conditional one, because that is the way, we don't go from one class to the last one, okay? Now, the moment we have that right now, okay, now, let me now explain this to you, because this is where we're going. We are actually we're going into what we call a Bayes rule. Reverend Thomas Bayes, 1759, said, and I quote, "If we have a belief," I told you the other time, that there is no mind that is empty. Anytime, any day we have something in mind. And what we have in mind will look like an hypothesis. I'm going to explain this to you now using what happened in the court of law. I'm going to explain this to you using what happened in the court of law. Okay? I want you to be thinking as if right now we are moving from our party, we are going into a court of law. We want to see what is applicable. We want to see how the knowledge of probability, how the knowledge of statistics can actually be applied in the court of law, in litigation. That's what we want to do right now. We're leaving the party. We're into the court right now. Okay. Now, take a look at this. Maybe there is something. Okay, are you guys hearing me?
Yeah.
Hello. Are you guys still hearing me?
Yes.
Okay. And you guys are actually seeing you see what I'm projecting, right? Calculation of posterior probability.
Yes.
Yeah.
Okay. Thank you so much for confirming that.
I think he just left.
Yeah, I think he did too.
That's in the chat.
Oh man.
We'll be teaching the rest of the class.
That was weird.
We'll be learning from the textbook today. Professor, we can't hear you if you're talking.
We can't see you either.
Oh, what about now? Can you hear me now?
Yeah, we can hear you
Yeah,
now.
we can hear now.
Dude, thank you so much. Now, let us pretend that something happened, an atrocity was committed in a particular area. And let us assume that, if you take a look at what I have here, is is an event that, an accused person actually commits, So that is exactly, I'm going to call that A, okay? I'm going to call that very A. I'm going to call it defendant is a source of DNA found at a crime scene. Okay, are you guys hearing me?
Yes.
Okay, now let me just assume that something happened and in a crime scene, a DNA was found and analysis was performed, analysis was conducted on the DNA found on the crime scene. Now, this guy right here is actually going to be, the hypothesis that the defendant is a source of the DNA found at crime scene. Okay. Now, when you take a look at the B right here, the B is an evidence. The defendant DNA matches that found at the crime scene. I'm going to say that again. A is an hypothesis before the court. Oh, defendant is source of DNA found at crime scene. B happens to be defendant DNA matches that found at the crime scene. Okay, and you know what? We are actually looking for evidence. Okay, and what we do is this. If we really want to start, we need to first start unconditionally. What do I mean by unconditionally? We need to first obtain marginals. Take a look at this guy here. These are marginals. We need to start from marginal. And that was why I said, what do we mean by marginal? In the court of law, we need to have a prior assumption. Prior. P-R-I-O-R. That's a prior. Now, prior assumption about the hypothesis. And what is the hypothesis right here is that the innocent, until proven guilty, okay, innocent is, the accused person is innocent until proven guilty. Okay, the accused person is innocent until proven guilty. Okay, and you know what? The idea of Bayes' theory is to be able to update our prior belief. We actually want to update our prior belief in the light of observing the evidence that we actually gather from the crime scene. What did I say we want to do? We actually want to update our prior belief. That's exactly what we want to do. And you know what? Updating our prior belief about A. Don't forget that I specify A. About A, okay? Then, if you update the prior belief about A, once we're able to observe B, which is an evidence, then this updating takes account of what I'm going to call the likelihood of the evidence. I'm going to say that again. The likelihood of the evidence. And what do I mean by the likelihood of the evidence? It's just like I actually want to update my prior belief. Okay? And what do I want to use to update my prior belief? I actually want to use the evidence that that we got from the crime scene. Okay, now Reverend Thomas Bayes, 1759, actually introduced a Bayes rule, in a way to update our belief. Because if something happens, we're actually going to have something in mind. How can we update what we have in mind? We're actually going to have a prior and we're going to have a likelihood. The combination of a prior and a likelihood will actually give us what we call posterior. Because there are two fields of statistics. We have people who use, we have statisticians who use classical idea, and we have statisticians who use Bayesian idea. Okay, those who use classical knowledge are those ones that actually believe in whatever they got from the data alone. But those who use Bayes' idea are those who would like to update. In addition to what we see in the crime scene, can we have a way, we have a prior belief. Can we have a way to combine? We're going to combine our prior knowledge, what we have in mind, and the data. We're not going to focus our attention. We're not going to base our results on the data alone. And that is the idea of Bayes. Because I actually wanted to understand this very well, and of course, I'm actually going to start from here in the next class, because you need to be able to understand the Bayes rule. So this is where I'm actually going to start from on Friday. Now, what we have left here is just, I'm going to show you after this. Then the only thing that we're going to have left is to go into example. And after the example, we are done. Can you see that now? But you know what? I'm actually going to start from here on Friday. Is there anyone who want to ask question or have any concern? Is there anyone?
I have
Oh,
a
somebody say I
question.
must leave. Goodbye. Oh, goodbye too, because I know some of you may have lecture right now. Okay, so for those who want to, for those of you that are leaving, please, if you actually want to ask question, of course, you can meet with me during the office hour, or you will even send a message to me by email. Okay, so is there anyone who want to ask question? Is there anyone? Somebody said, when is homework due? Of course, homework is going to be uploaded every Monday night, and is actually going to be due every Sunday night, 11:59 p.m. And some of you have been submitting your homework, through the email. You don't do that. You have homework one part on Canvas. All submission should be done to you actually have to submit to the homework one part on Canvas. Please don't send your homework to my email. Okay, you're going to send it to there's homework one part on Canvas. Somebody said, what do we have to show for our answers on homework one? Now, let me tell you this. What I want to say in the homework one, okay, when you're given any mathematical problem, of course, you need to you need to state your method. Then after your method, then your answers, okay, I just want to see, okay, if you get any result, if you get any answer, okay, what are the approach? What did you use? What formula did you use? Okay, so you don't need to write anything much, but what I just want to say, oh, this is the method I use and this is the result. Somebody said, are we going to submit it by handwriting or doc? Now, let me tell you, under normal circumstances, if the situation were perfect, what I would have loved to have is, submitting, you need to type it. But you know what? We're in the middle of pandemic and everything is not perfect right now. Then it depends on you. You can write. It could be handwriting, but make sure when you are writing, it has to be legible. It has to be clear for grading. Okay. So when you do that, then you can actually, you can take a picture of that and save in the PDF. Then you can plug it in. Okay. With future homework, have arrow coding on them. Oh my God. Yes. Uh, the assignment one, you have not really done something much in the lab session, okay? And you know what, in the subsequent exam, in the subsequent homework, you're actually going to there's going to be a part for her, because all what we're doing manually, we can also, do that using the software. And the essence of the software is to aid computation, okay? We want to get our result on time. Our test open notes or anything like that. Oh my God. Okay. I'm going to give you detail about exam on Friday. The detail about exam, the exam is all exam will be conducted online using the quiz on Canvas. I'm actually going to have a demo about how that is going to be. But you know what? The exam is going to be a combination of multiple choice and short answer questions. And let me just give you right now, for those of you that are still waiting, because it's being recorded. Even if you are leaving, you're actually going to capture, you are still going to listen to this video to get what we just talked about. Now, let me just give you how the exam is going to be. Based on your question, the exam, I can confirm to you the exam is actually going to be an open note. It's going to be an open note, but there are several ways to ask probability questions. So all what you need to know is to be able to get what is the appropriate statistical methodology do I need to apply when I'm giving a question. Now, the strict instruction that I'm actually going to put in the exam is that you have to sign an honesty statement. And the honesty statement is that you cannot, when you are writing your exam, you cannot seek assistance from anybody, and nobody can seek assistance from you. But you know what? When you are writing your exam, you have all the sources in this world to extract from. So that is why you can open your note, you can open your textbook, you can open anything. But you know what? You cannot share knowledge. We got a way to monitor that. And that was going to be part of the honesty statement that you guys are actually going to sign. But like I said, probability questions, they are in millions, they are in billions. And you know, question comes in different forms. All what you just need to be able to do is just, okay, what is the strategy that I'm actually going to apply? That's all. That's all you need. Okay. I think I've answered that. And you know what? Like I said, the exam will be conducted using the quiz. The quiz. There's a quiz section on Canvas, and I'm actually going to time you guys. Let me put it to you. The exam is going to be 2 hours. Okay, the exam is going to be 2 hours, but for those who have DRC letters that have informed me, because if you have accommodation, you have a DRC letter, you actually need to send a message to me privately, not now. Don't send it to me now. Privately, send it to my email. Okay, those that have that letter will spend 3 hours, but those who do not have that letter, you know, you're going to spend 2 hours. And you know what? Let me tell you what I normally do. I'm going to leave the exam open for 24 hours. But only that, you can only spend 2 hours on it when you click on start. When you click on start, of course, it's going to be counting down. Okay? So, and I'm going to tell you, those who have a DRC will spend 3 hours on the exam, and other students will spend 2 hours on the exam. And you know what? I'm actually going to leave the example open for 24 hours. Why am I doing that? I'm doing that because I know right now some students are not in this country. They are in a different time zone. And even in the United States, you know, some people are in different time zone, even in the US. And that is the reason why you can decide to start at any time within the 24 hours window. But you know what? The moment you click on start, it's actually going to be counting down. Okay. In the absence of other question, somebody said how many questions, of course, like I said, I'm going to discuss. Now, let me tell you this. Before any of my exam, I normally have practice questions. And I'm actually going to walk you through practice questions. That's what I do. In every exam, that's what I do. Whether you are writing a midterm 1, midterm 2, and the final, that's exactly what I'm going to do. So before the exam, there's going to be a practice questions. And in the practice question, of course, I'm going to walk you through that. Okay? That's exactly what I'm going to do. Is there anyone, somebody said, is it on syllabus? There are some information that are not on the syllabus. You know, when you look at model exam, although I put the date of the exam, but I said detailed information later. That was what I put. Okay, and like I said, part of that detail is what I'm giving out right now. Yeah, exams are October 14, and you know, check the syllabus. You know, the date of the final and the date of the midterm 1, midterm 2. They are on the syllabus. Okay, I want to thank everyone for attending my statistical and probabilistic party today. And I hope you guys really enjoyed the party. And we're going to continue from this party on Friday. If there is any one of you who gets stuck, if there is any one of you who is struggling, please ask questions. Send a message to me. I got a way to walk you through whatever you are passing through, because I actually want to be everybody's friend. Because when you are good, the society is good. Okay, make sure you stay safe, everyone. Until Friday, we meet again. Bye for now. Bye, everyone. Yep. All right.
Thank you. Have a good one.
Welcome.
Thank you.
Thank you.
You're welcome. You're welcome.